Hello. Welcome to a evening stream. Just to give people in other time zones a chance to see. Because it's the evening and I live in an apartment building, I can't be noisy after 10. And so this stream will either last for 1 hour or at the 1 hour mark, we will go into ASMR mode. Most likely it'll just last an hour. Oops. That's incorrect. Fix that tweet. All right. So earlier today, we got this working. Yes. That was in Mesh from Voxel Job? No, it's in, which one was that in? Voxel Fragment. Oh, Voxel Vertex, actually. Yeah, okay. We got this working, which is the basic GPU builder. And it's making the holes in the walls by putting in, drawing the walls as big slabs and then cutting holes in them. So it's doing a little bit of CSG. And one thing we noticed is that the cull time has gone up a lot because now we actually have a significant number of items in it, because every window is a separate command list entry. And I'm thinking about a couple things. One is that I want to get the window sills incorrect, which means I need to have the interior versus exterior texturing distinction. 2, I want to bring that cull time down. 3, if the buildings are realistically scaled, we can't fit very many buildings in a 256 by 256 chunk. We might make the buildings lean to the small side so that you can like run by buildings faster. There's more variety of buildings. But even then, it's going to be a little difficult. So I think the road network generation might want to work at 512 by 512 or 1K by 1K chunks, and then freely place everything within the 1K by 1K chunk rather than worrying about where it falls on the 256 by 256 entries. Now, partly this is because we changed the old program that I was using was 1 voxel per 2 feet. And if you did like a voxel per meter per 3 feet, you'd be able to get a pretty realistic thing, I think, in 256 by 256. But this is now at 1 voxel per 1 foot. And it's nice to have thin voxels, to have thin walls, thinner walls, which you can't quite see very well because it's not a separate texture. So what I want to do is try to do the culling but do the window sills first. And I left this with, there's this texture screw up right now because I tried to rescale the textures and it doesn't work. But I'm just not going to fix that right now. I want to get the interior exterior texturing working. So the way that works is that command lists have let's change the command lists to that format. The 10-bit Z. We know we don't want to go bigger than 10-bit Z anyway. So having that extra padding, it's just stealing bits that we can't use for anything else. Let's make them 11. Just to future-proof a tiny bit. All right, so 11 bits. So we need to go through everything that looks at the Z. I think the color doesn't look at the Z. No, it doesn't. This one does, but we don't use it anymore. And then this one is the one we're actually using. Okay. I don't think we do it anywhere else. So, because we're going to need those bits. So, we currently, only the texture system cares about this. So, we get text 0 and text 1 here. And we want to know for each voxel which one to apply. So what we want to know is, are we at the extremes of the region? So we need to preserve the original x0, x1, y0, y1. And then create new locally clamped ones. Which come from R. And then we say int on extreme axes. Extreme axes equals x equals x0r or x equals x1r. Okay, these are in inclusive exclusive pairs. So here we want to convert it to inclusive to simplify the inner loop. Let's not use let's do this. So now it's inclusive exclusive. So we can say if it's at the extreme, then that's an axis that counts. If it's at the extreme, that's an axis that counts. That's on extreme, that's an axis that counts. Then, if you're at 2 extreme axes, then you use text 1. Otherwise, you use text 0. Actually, text 0, text 1, I think. Oh, yep, sorry, I forgot to switch views. Thank you for pointing it out. So all I've done, these are new variables derived from these. I renamed these. So then these are the old variable names, and now we're preserving the original values. And then this is the converting from inclusive exclusive to inclusive. And then we count for each axis, are we at the extreme of that axis? And if we're at the extreme of at least 2, then we're on the boundary, the edge boundary of the thing. Now I want to make sure my main, when we're drawing the buildings, puts some different data in these. So let's see if that works. I did not do Z0R. Do we clamp our Z's? We do not clamp our Z's, so we don't need that. Stream axes. Okay, so now you can see that these outer slabs are one texture. The outer borders here are one thing, and there's no roof or floors. This one has floors. This one does not have floors. Oh, they don't go all the way up. Let's worry about that. Height times floor height. Height is floors times floor height. Z base. Z base times floor height. Why is this not right? Why did these disappear? And oh, anyway, so so we actually want to put in the slab yeah, we want to make uint text text east west uint text north south uint text up down, and that we return text EW text EW should be 5 text north south should be 10. This is how there's actually 10 textures encoded in each one. So we have to encode equal twice. So then we say this is a texture along the y-axis. So so we want to pack text 1. So along the y-axis, so x should be special. 4, 1, 4. Maybe like that. I'm not positive. And then this becomes 1, 4. We kind of got it. We got that, and that, but we didn't get that and that. And it's still showing on the extreme corners as well, which it shouldn't. Does that mean we have these backwards? Let's just do that and check how that behaves. No, because we wouldn't. The window should be consistent on both sides. Okay. We're not handling inclusive exclusive right, or we're not handling north south right. Oh, this is because I didn't correct these to line up, so it's easy to not see what they're doing. Still not right. Why are the two sides not correct? Is that not the order the sides are in? Are they in the order east, west, north, south or something? Mesh from Voxel Job. Make voxel face pair. Text 1, text 2. Wait, what? Make voxel. Oh, make voxel. Text positive, text negative. Oh, I don't think that's the order I want that to be in. Oh, I guess that's cleaner. So it's east, north, east, north, east, north, up is the order. So it's east, north, up, east, or west, south, down. Okay, so yeah, there's a different texture on the interiors of the walls. Why does that not go up to the top? Why is the floor spacing wrong? This used to work. Did we change something? We changed how Z worked in these things. We changed which bits to use for Z, and we might have screwed that up. Oh yeah, we never did it in the C code. We only did it in the shaders. This is shift 15, this is shift 15. Okay. Yeah, okay. So that's what we were trying to get to. So now the interior exterior thing is working. The top face is 1 too high. Here's the top face. Oh, no, that's not the top face, that's the regular ones. That's the top face. And the top face gets a different texture than everything else. And you can see, like, need to clean this up. But what we can actually do is make a little roof by having these go up, say +3. So there's a little roof with a low wall around it. So yeah, I think that covers that. And so now what we want to do is improve the culling speed. So let me check that in. Yeah, now this is already actually visually superior to the old ZMC because I didn't do any variations on the buildings. Here's the original project from more than 10 years ago. Yeah, obviously has the more sophisticated, how did I fly? There we go. Has the more sophisticated ground. Oh, it does have multiple colors for the interiors and the roofs. Oh, I did do varied window sizes, actually. But I didn't do window different textures on the window frames. So, and I didn't do the little roof thing we just added. So, how do we make the mesh culling go faster? So right now, the culling, we produce a separate cull for each 8x8 subsection. We cull down the command list to only the things that cover that 8x8. And that means there's 32 by 32 of them in a 256 by 256. And we have one SIMD lane does each 8x8, so that you can have 32 SIMD lanes all processing one 8x8 parallel. They all iterate through the main lists at the same time, exactly synchronous, and each one generates the thing. But that means there's only 32 total jobs running, and that's not very many. Now, one thing we could do is we could do even more finer culling. Instead of culling for an 8x8 by 1024 tall thing, we could cull to like an 8x8 by 64 tall to have fewer things overlapping each one, and we might do that in the future. But that's just going to generate more work. It is going to, we'll have more than 32 jobs because now we can have more jobs stacking up vertically, but it's not going to help get more parallel. So to get more parallelism, we need not to assign lanes to individual 8x8 groups. We need to assign lanes to something finer grained than that. And the thing that we have that's finer grained than that is the command list itself. We can assign each one to a different command list entry. And each one can decide, does this command list entry overlap this 8x8? So, how do we do that? Well, the easiest thing to do that we're going to do is we're going to make sure every command list entry is the exact same size. So currently the slabs are 4 D words and the CSG subtracts are 2 D words. So we're going to add 2 more unused D words. And the color needs to parse that, but the output, we can go back to it only being 2 if we want. But it'll probably be easier if we just keep it all the same for now. So now let's see, did that work? Oh no, because we now got parsed the erases. So now this always happens. And build texture grid. So that might be right. Yeah, it looks right. So now all of our things are the same size. So we go to our command list color and we say our local size is going to be 32. Our global invocation ID, we don't want to use that. We want to use work group. What is it? Work group. Work group ID, is it? Yeah, work group ID. So we're just going to use that to offset into the list. Okay, so now what we do is we iterate through all of our commands. And we say I is going to step by 5. So we want a command number, and actually K is our command number conveniently. So instead of I, we say k times 4. Sorry, I don't know why I said it was 5. It's 4 t words long. So we can just say I equals k times 4. And let this increment I like it normally does. And then this can just share. Everything is going to use the same layout of XYZ for culling, or XY for culling. So everything can work this way. Well, that'll just be a requirement. Everything has to use the exact same structure. And then I can use the OpenGL things for it. This will allow us to potentially control it from the source code sides. We could pass in the definition when we compile it if we put it on a macro. So then K is going to step by workgroup size. Runs at most 4,096 times. Then I, so then the int slot equals K plus GL local invocation index. Let's just use ID. And then I is slot times 4. So now we have 32 SIMD lanes, and they'll each pull out a different item. Now they need to know where to write to J. So we do a shared in output slot. We need to use the subgroup stuff. I don't know. Do we have somebody who does that? It was in that the code to vote. Where did that code end up? It's in here. Find the first active lane. We want that code. Color. Well, I guess, yeah, that's fine. GL subgroup invocation ID. Invocation ARB. And we say output slot equals 0. And this is running in lockstep, so we don't care. Now, this will not work. This is going to be going to lose. This may happen to work out and be the correct ordering, but it goes output slot times 4. Which now becomes count. But yeah, there's nothing in the code guarantees that these go into the right order, because you have to preserve the order of the input list and the output list. Now we've changed it so one work group is just working on a single 8x8. So when we dispatch this, we have to actually dispatch 32x32. Let's actually do 256 over 8. 256 over 8. I'm sure that won't work. We'll probably get compile error, actually. Yep, 59. Yeah, these are units. Well, we've culled everything out. And the color is slower. Why is the color slower? Oh, maybe because of all the atomics? This should only be being written by one person. How are we computing out base? From pos.y and pos.x. Where is pos coming from? Work group ID. That seems right. What am I missing? Okay, let's have only one lane do all the work. And so it'll step by one. Okay. Why does this not work? Now the color takes a long time. Because we're not offsetting by outbase. I think. Well, that was definitely a bug. Oh. +1. Okay, so now we've reconstructed this here. Outbase +1. Plus output slot times 4. We need to 0 output slot. We do. This num commands logic is all wrong. K is less than num commands. But I don't think that would just cause the loop to run extra times. What have I changed that would break? Okay, well, it totally changed the structure. Let's make this not shared. I think there should be an error. You shouldn't be able to atomic increment it. Yeah. Now it's really slow. Okay, good. So that's busted. But I mean, it's okay. So if we put the output slot locally, I don't know why it's inconsistent, but oh, because all of the No, because this should only be one subcommand running. But anyway, okay, so it was basically generating all the data. So it seems like output slot being shared is breaking. Okay. Now if we cull it. Okay, why does culling not cull to the right region? X0, Y0, X. These seem like they're wrong. But we get them from pause, which is work group ID. And we're running 32 by 32 of them, right? Culling, program color, 256 over 8, 256 over 8, comma 2. So we're running 32 by 32 of them. How long did that take? Still taking a millisecond, so it is doing a bunch of work. I don't understand why it's slow. Oh, I do know why it's slower, because now we're doing it this way. Because we're not doing it in parallel. This needs to be offset by 1 because of this. Well, how is this even coming close to working? I'm so confused. Num commands, command list of I++. So I is 1 here. But yeah, this is misinterpreting the data in memory. We've lost an I increment somewhere in here. And this now needs to be I+2, I+3. So let's get rid of all the I increments except at the end. Okay, yeah, now it's correct. Then put that back. Why does that fail? What? Why is this failing? I don't understand. How are these not doing the same thing, basically? I haven't really thought about lighting. We've lost some of our Z heights here. Are not getting passed through. So this isn't quite right. Yeah, that shouldn't change anything. All right, so this already isn't quite right. We're losing a little bit of data here. What? Why would we lose a little bit of data here? It's num commands, right? Nope, that's exactly the same. Doesn't quite go to the top. Why are we losing some of our floors in both of them? The floors are the last things we draw. So that kind of implies they're being overwritten by the next things, but that we didn't change that. Okay, is every work group working on a different 8x8 region? Yes, because we use work group ID. Time's running out. 20 minutes. 15 minutes. What? Why would we lose some commands here? How does this not work? How do we lose some output commands? We always increment output slot. We should do it at the end. Yeah, that was that. Okay. So we were doing the increment in the wrong pot. But if we do the atomic add, it should go there. Because the atomic add returns the old value. Right? It does. Surely it does. GL SL atomic add. It returns the original contents of mem from before the addition occurred. And we get nothing. Our atomic add is just not working. Why is it not working? I don't understand. Why does this not work? What happens if we do both? It's like the atomic add is just being suppressed entirely. Why? Why is the atomic add being suppressed? Is this... Just making sure I'm not forgetting how this works. All invocations within a work group. So it's a separate one for each work group. And only one invocation must do that. So only one invocation right here initializes it. The atomic add what happens if we put this at the bottom? It shouldn't make any difference. I don't understand. Why is this not working? How can this fail? I mean, this is just trying to debug it. We could just go back to actually doing it in parallel and not try to debug this, because maybe this is a compiler bug. I don't understand how this goes wrong. Hey, look, we get some data. Now, the only thing that should go wrong is that they should be potentially out of order, and that would mean that the windows might get removed, try to erase CSG subtract from something that's not there. So the only thing that we should be able to have go wrong is that our windows are missing. But obviously, a lot more is missing. So there's still something else going on here. We know this is all in sync, so that's just unnecessary, but yeah. It's kind of like maybe only getting, well, yeah, I don't know. It's hard to say what's going wrong here. Like, clearly this is some kind of chunk boundary failure here. Oh, that's interesting. The meshing is just wrong. So we're actually, well, no, that makes sense, because the culling is just inconsistent between adjacent things. Oh, yes, thank you. That is exactly the problem here. Oh, so dumb. Thank you. That's all it was. And yes, so now the parallel thing is working correctly. And look at our cull time. It's down to 0.05 milliseconds. Now there is one bug, which is that, as I said, there's no actual guarantee these get produced in the right order. They probably just always do. Probably the hardware just guarantees that the atomic adds happen in order. But the correct way to do that is with this atomic append so this like is explicitly using counting bits of the lower numbered lanes to determine a prefix sum. So that is atomic append offset pre. Offset. So then bool is in equals this. Let me say atomic append offset pre is in offset and then atomic append offset post this returns a single value across all this returns this number from the lowest numbered active lane. This is not out. Wait, what does this one do? Yeah, okay, in offset. This, as it mentions, this code is untested because I did the 2-bit one. I guess we should just use the 2-bit one first to make sure. Atomic offset pre 2-bit count pre, because we know this one works. Int count. And then let's find where we're using it. Is that this one? Maybe we no longer use it anywhere. Oh, here it is. Okay, so this is the usage pattern. Cut and paste that in so we can see it. So we offset if it's less than 0. Then we don't do anything. In the lane where it's non-zero, we write out the increment value. And we don't need any of that. And then offset, well, OS that. I think that is correct. Util. There we go. Oh, val, not value. Index into mesh data. We didn't rename our thing. Output slot. This doesn't need the cast. And that is not correct, but it is still fast at least. So we add 1 if is-in is true. We don't use OS. What else am I missing? We atomic append. We output to offset. Then we use offset combined with value. Let's look at what the code actually does. It just returns result plus offset, where result is the lane with the good value. Okay, so result is the number of set of increments. We return that in result, which is value. No, which is offset. Wait. No, we return it in result, which is value. So one lane, the value is non-zero. And we pass value in along with offset again, where offset was the count of the previous lanes. So we get here, result is either 0 or the total number added. And here we extract the total number added. And then we add the offset that we just computed. That seems right. So this OS should compute the output slot. Yeah, don't worry, the fact is not obvious. What what am I missing? I'm just doing something wrong here. Much like I was doing something wrong. Thank you again for catching that incorrect use of atomic add. Am I doing that again? No, I'm doing it correctly this time. This is only valid in the one lane that was non-zero. We get back that value though, and we extract inside this function, we extract that to all lanes. So that's right. We're using 1 and 0 for count. Out in offset. I don't know. This looks right. And I've hit my 1 hour mark, so I gotta go quiet now. I could probably go for half an hour without getting into trouble since it's the weekend. What am I missing? What else? What is going on? Okay, let's do it the naive way again. Make sure we didn't break this. Yeah. So if we do it the naive way, it still works. could just switch it off the 2-bit version, but in theory, we know the 2-bit version works. Did I actually ever use it? What version was this in? Was it this one? I don't remember which one used that. Like, maybe I shouldn't be believing that it's correct? Dang it. I don't know. Well, we'll just use this approach for now and come back and fix it correctly later. But anyway, so that did the thing I wanted. We now cull efficiently. And we produce the exact same results that we were before. So that was what I wanted to get in this 1-hour stream. I wanted to get done were those 2 tasks. The interior exterior, so we got the window, the using different voxel textures on the interior and exterior. That's a weird way to describe it, but that's what it's called internally. And now our total mesh time is 20, 35, 38, 45, about half a millisecond. And we're only probably doing maybe about a sixth of the work. So this would come in at about 3 milliseconds once it's super sophisticated, and slower for taller buildings, because this is only going up to a third of the height that it can. We can have a really tall building. I think it's about a third. Except it's a new map. I don't remember what the new map does. Oh, it's in terms of the 24 floors and each is 12 tall. So that's 288. So yeah, it's only a quarter of the possible height. Let's use tall ceilings, and if we did 100 of them, that's 1600. That's too tall. So 50 is 800 tall. Yep. So that's how tall a building can be. So in a chunk that with a really tall building, there's just going to be that much more processing to do. But then there need to be interiors and a lot of other complications. So, you know, there's twice as many buildings, so it's twice as much stuff to draw, but then all the interior detail. So I'm guesstimating 6 times the complexity. So 3 milliseconds for buildings like this height, and slower if there's a taller building. But anyway, that's all I want to do in this stream. So any other questions before we wrap? Does that check in? What did we do? Okay. Well, no questions, so I will end the stream. Thanks everybody for showing up for this short stream. Oh, here's a question. Is VC6 important IntelliSense for hiding potential errors in real time? I don't know if there are versions of Visual Assist that work with it, but yeah, I do not think there's anything built in for error handling. There might be. Where is that? Yeah, no, I think statement completion is the only thing it has. IntelliSense post dates. Yeah, I think that's where it would be if it was anywhere. There might be coloring for it, but I doubt it. Yeah, no. So yeah, I would say it does not. I don't generally like that kind of thing. I want, so like, I consider things like tab completion in the shell to be often a kind of inefficient operation, because like in Windows, tab completion will let you cycle through all of the things that match. I think the Unix standard is it doesn't tab complete if it's not unique. But it becomes interactive. You press a key and wait and see what it does and then decide what you want to do. And so I tend to avoid using things like that because my brain wants to just keep going linearly with what it's doing and not stop and wait for a thing to happen. So for example, I used to use this tool for changing directories, where if you wanted to say do that, it's Windows, so it's that. If you wanted to do that, you can do CD, F, press tab, B, press tab, H, press tab. And maybe that works if those are the only ones. But I used to have a command called go, or I just abbreviate it to G, where you would just type that and hit enter without any tabs. And if this had a unique expansion, so like there could be two Fs in the top, but as long as only one of them had a BH under it, then it would jump to the correct directory. I don't use that anymore because I just don't do enough CDing in the command window anymore, as I've migrated to using Explorer more. But anyway, so on that same principle, I don't exactly tend to use even just the basic autocomplete. Like we've talked about that with AP here. That I do use it for this because it's effectively sort of a documentation thing, but I navigate the menu. I'm not like typing keys usually. So like K enter is enough to do it, but I'm more likely to just type out keys because I can just let my brain go. And so for that reason, I've never really pursued any of the IntelliSense kinds of stuff, even though showing errors is not that kind of interactivity, but it is this interactivity of highlighting an error, but I haven't finished typing, so it's not an error, it's not actually a valid error and stuff like that. So I tend to not like that kind of tool. So I don't even know if maybe there's some way to get it in VC6, but probably not. All right, since there's no other questions, we will wrap there. Thanks everybody for coming and hanging out. I hope you enjoyed it. I'm going to, as I always do, I forget to do this advanced check what my viewership is out of curiosity, since this was a weird time, trying to make it open to other time zones. Yeah, we're under 100, as I would expect. I mean, it's a Saturday night, come on. But yeah, all right. See y'all.